Welcome students, we have got this question: p times root of p positive q times root of q is equal to 3 and p times root of q positive q times root of p is equal to 2. Now this question is easily solvable if we do not have this 3 and we do not have this 2. So what I want to tell you is, if you got something more composite number on the right hand side for both this system, then it would be easy to solve. But in this case we got 3 and 2 which aren't composite numbers, and so we would, in fact the only factors of 3 would be 1 and itself, and the only factors of 2 is going to be 1 and itself. So we just got two prime numbers, and to solve it we need to have some patience and some meticulous process. So first what I'm going to do is I'm going to start off with this assignment. I'm going to say let root of p be equal to some x and let root of q be equal to some y. So if I were to square both sides, this is going to be my p equal to x squared, and this is going to be my q is equal to y squared. So we can substitute. So hence the new system is, so in place of p I will be substituting x squared, in place of root p I will be substituting x, followed by, in place of q it's going to be y squared, in place of root q is going to be y is equal to 3. Of course this can be rewritten as x cubed positive y cubed is equal to 3. So I'm taking this as 1. Of course we can take this as 1 prime and take this as 2 prime. So I'm starting with this equation 1, and also in this case this is p is going to be x squared and root q is going to be y positive, q is going to be my y squared, and root p is going to be my x is equal to 2. I can rewrite this as x squared y positive y squared times x is equal to 2. So I take this as equation 2. Now what I'm going to do is I can rewrite rewriting 1 as x cubed plus y cubed. I can rewrite x cubed plus y cubed as x positive y times x squared negative x times y positive y squared. I can rewrite this. So y, if I were to take x is equal to 2 and y is equal to 1, this is going to be 2 cubed, that's 8, and y cubed is 1. On the right side 2 positive 1, 2 squared, so it's going to be 4. Negative 2 positive 1, 4 negative 2 is 2, 2 positive 1 is 3, over here is 3, so 3 times 3 is 9, and 9 is equal to 9. So I just did all these things to show to you that this is a valid expression. So I'm going to take this expression and I'm going to substitute it here. So that's exactly what I'm going to do. So this is going to be x positive y times x squared negative x times y positive y squared is equal to 3, and x squared y positive y squared x. What I can do is I'm going to take x into y out, so this is going to be x positive y is equal to 2. So this is my equation 3 and this is my equation 4. Now what I'm going to do is I'm going to divide 3 by 4. So when I do that, this is going to be x positive y multiplied with x squared negative xy positive y squared is equal to 3 divided by x into y times x positive y is equal to 3 over 2. This is what we are getting, right? So x positive y gets cancelled, and I can rewrite this as x squared negative x into y positive y squared divided by xy is equal to 3 over 2. Now I can cross multiply. If I cross multiply, I would get the following. I'm going to get 2 times x squared negative x into y positive y squared is equal to 3 times xy. Now this can be rewritten as 2 times x squared negative 2 times xy positive 2 times y squared is equal to 3 times xy. If I were to move this to the left, I'm going to use this space here. This is going to give me 2 times x squared negative 2 times xy negative 3 times xy positive 2 times y squared is equal to 0. I can add these two. This would give me 2 times x squared negative 5xy positive 2 times y squared is equal to 0. This is what I'm getting. Now what I'm going to do is I'm going to be dividing by y squared. So if I do that, this is going to be y squared, this is going to be y squared, this is going to be y squared. The 0 by y squared is going to be 0. So this can be rewritten as rewriting we get. So what do we get when we rewrite? This is going to be 2 of x over y the whole squared negative 5 times a y and a y gets cancelled, giving me x over y positive y squared gets cancelled. So this is going to give me equal to 0. Now what I'm going to do is I'm going to say let x over y be equal to some t. So if I were to take it like that, then this would become 2 times t squared negative 5 times t positive 2 is equal to 0. This, which is a quadratic equation in t. So if I were to solve this, I will get t is equal to negative b is going to be, so if I were to write this, my a is 2, my b is negative 5 and my c is equal to positive 2. So negative b is negative 5 plus or minus square root of b squared negative 5 squared negative 4 times a times c divided by 2 times a. Now I can rewrite this as 5 plus or minus root of 5 squared is 25 negative 4 times 2 is 8, 8 times 2 is 16 divided by 2 times 2 is 4. Now this is equal to 5. Now 25 negative 16. So that is going to be 9. So plus or minus root of 9 divided by 4. I can rewrite this as 5 plus 3 divided by 4. That will be one thing. Or 5 negative 3 divided by 4. So this is 8 over 4. So therefore t is going to be 8 over 4. Right? So that's going to be 2. And t is equal to 2 over 4. That's going to be 1 over 2. Now but the value of t is what? This is the value of t, x over y. So this would mean I get x over y is equal to 2. And then I get x over y is equal to 1 over 2. This is what I'm getting. X over y is equal to 1 over 2 and x over y is equal to 2. Now 2 is nothing but 1. Now I can suitably take x to be equal to 2k and y to be equal to k. Okay, for the fact that since x over y is equal to 2 over 1, which is nothing but 2k divided by k, which is going to rebound to my 2 over 1. Right, so I'm taking x is equal to 2k and y is equal to k. Now if I were to make this substitution, okay, where am I going to make the substitution? I'm going to make this substitution all the way coming over here. I'm going to make it over here in 1. So I feel that is the best possible equation that would give me the values for k. So substituting, so I'm just going to write here, substituting x is equal to 2k and y is equal to k in 1. So what is my 1? My 1 is x cubed. So I'm writing down here x cubed positive y cubed is equal to 3. So I'm substituting it here. So this is going to be x is equal to 2k raised to the power 3. Y is equal to k cubed is equal to 3. So this is going to be 2 power 3 is going to be 8. 8 cubed positive cubed is equal to 3. I can rewrite a cubed plus k cubed 8k cubed plus k cubed gives me 9k cubed is equal to 3. This is going to be k cubed is equal to 3 divided by 9. So therefore, I get k cubed is equal to 1. 3 divides 9 3 times. So k cubed is equal to 1 over 3. So therefore, my k is going to be third root of 1 over 3. So this is the value of k. Now already we know that x is equal to, so this would mean since x is equal to 2k and k is equal to this, third root of 1 over 3. So this would mean, I substitute the value, so this is going to be 2 times third root of 1 over 3. This is my value of x. And my value of y, my y is going to be simply, the value of y is simply going to be k. So y is going to be third root of 1 over 3. This is going to be my value of x and my value of y. But what did we do? But we have got the value of p, but p is equal to x squared and my q is equal to y squared. Right? So this would mean if I were to substitute the value of p, substitute the value of x over here. So this is going to be my x value I'm substituting 2 times third root of 1 over 3. So that's going to be, let me write it down, 1 over 3. This entire thing is raised to the power 2. So this, I'm going to rewrite this as 2 times 1 over 3 raised to the power of 1 over 3. This is raised to the power of 2. Of course, this has to be a square there. So I'm placing the square there. So if I were to expand this, it's going to be 4 times of 1 over 3 raised to the power 2 over 3. So this is going to be my value of p. So if you want to write this further, this is going to be 4 times. I can write it as third root of 1 over third root of 1 over 3 raised to the power of 2. Right? This is exactly what is it. So you can expand this further. If you want to expand this, this is going to be 4 times of third root of 1 over 3 raised to the power of 2 is going to be 1 over 9. So this is the value of p. Right? Now the value of q is nothing but y squared, but my y is this. So this is going to be 1 over 3 raised to the power of 1 over 3 raised to the power of 2, which I can rewrite this as 1 over 3. I can make this a square and move this 1 over 3 down there. So that's going to be 1 over 9 raised to the power 1 over 3. You can just substitute 1 over 3 there. So if you were to substitute 1 over 3 there, you would get this value. So this is my p, this is my q. The question is, if I were to perform a check, okay, I want to perform a check. So I'm going to show you the check here. So let me show you the check here. Now it's time for us to check. Now we've got this. We started with p times root of p plus q times root of q is equal to 3. Now if I were to rewrite this, this is going to be, let me use the space, p raised to the power 1 times p raised to the power 1 over 2. So this is going to be p raised to the power 3 over 2. So I'm going to place that p raised to the power 3 over 2 plus this is going to be q raised to the power 3 over 2. Now I need to get this 3. Now the value of p is this. So I have to take this value and I'm going to place it here. Now instead of using this value, I prefer to use this value because this is going to be equal to 4 times of 1 over 3 raised to the power 2, that is, it has to be raised to the power third root. So this is going to be 1 over 3 raised to the power of 2 over 3. So this is the value of p. It's better for me to use this. So I'm going to place that value here. So it's going to be 4 times 1 over 3 raised to the power of 2 over 3. That has to be raised to the power of 3 over 2. Plus the value of q, I'm going to use this 1 over 3 raised to the power 2 raised to the power 1 over 3. So that's going to be 1 over 3 raised to the power of 2 over 3. So there's going to be 2 over 3 there. That has to be raised to the power of 3 over 2. Right? So this is what we have got. Now, if I were to rewrite this, let me show you how it comes out. So let me just rewrite the entire process. So what we have got 4 times 1 over 3 raised to the power 2 over 3. This is raised to the power of 3 over 2. Positive 1 over 3 raised to the power 2 over 3. This is raised to the power 3 over 2. So we are trying to get the right hand side. Now this is going to be 4 raised to the power 3 over 2 times 1 over 3 raised to the power 2 over 3. That is multiplied with 3 over 2. Positive 1 over 3 raised to the power 2 over 3 multiplied with 3 over 2. Clearly 3 gets cancelled, 2 gets cancelled. So you got 1 over 3 here, positive. This 4, I can rewrite 4 as 2 squared. So that has to be raised to the power of 3 over 2. Now in this case 3 gets cancelled, 2 gets cancelled, giving me 1 over 3. Now this is going to be 2 can be cancelled. So this is going to be 2 power 3 with 1 over 3. Positive 1 over 3, this is equal to, now 2 power 3 is 8 over 3, positive 1 over 3. Now what is this? 8 over 3, positive 1 over 3, the LCM is 3, so it's going to be 8 positive 1. 8 positive 1 is 9 divided by 3. So 3 divides 9 3 times. So this is equal to right hand side. So this is the solution, students, for this beautiful problem that we started. As I mentioned to you, to solve such questions, we need some patience. Thank you, students. See you in the next class.